So, what we have done is essentially looked at how electrical engineering can be applied for health care. That is the motive. See, although we have put electrical, electronic and high voltage, it is only people tend to use it. Everything is electrical, remember that, it is all electrical science. Compartmentalizing is not the right thing, and I am very this thing about it because Indians have a tendency to compartmentalize. So, we have to come out of that. It's a, and we have seen how useful it is going to be to make health care useful, and in that direction I mentioned yesterday also, Lord Kelvin had told us that no engineering or science is useful unless we measure it, and measuring today's contest means digital measurement. It is taken for granted. A digital instrument is an electronic instrument, and if you remember correctly, electronic instrument is basically a voltmeter and an electrical instrument is basically ammeter. And the second difference is electrical instruments are passive, electronic instruments are active. First thing, another thing which you should remember is electrical instruments draw a portion of the power required from the quantity that is being measured, and therefore they load the system, whereas active instruments they do not load the system when you take care of the impedance, and therefore a transducer is very important. And since we are trying to measure potential, we talked about how potentials arise in the human body, which are termed as biopotentials. Not necessarily human body, human beings, it could be even animals. That is why it is a biopotential. And how we can measure biopotentials from the vital organs like heart, brain, and you look at the body and say how the person is. Therefore, skin is a very vital shield for the human body, and we looked at those things. So, we had some idea about how to compute those things. So, now we move from there, look at the devices today, and that is what is Professor Sundararajan will take over from here.
How many of you wear the wearable watches? Do you use any one of you? The iPhone watch, nothing? Okay, everybody wears there because that will count your number of steps, your heartbeat rate, and then energy or calories spent, this and that, so that everyone can, they will brag. That is what in the class. Oh, I walked today 10,000 steps, I only walked 2,000 steps, like that, okay. Once we went to Germany last April, we walked 17,000 steps because there you have to walk everywhere. Our guide took us everywhere by walk. I was tired, but it was really good. Okay, so we wear that watch. Nowadays it is available even for $50 there. I do not know about here. So, what is that is the medical devices we can wear, and then we will be the messengers to send the information to the doctor. So, no need to go to the doctor. If you see, I did not bring that book, afternoon I will bring. In the Fortune magazine, they are talking how using, if you did not know, they revolutionized their economy using Nokia cell phone, because they do not have banks, they do not have electricity grids, but using, cell phone, they will know what is the price in the market to sell their goods. Like that they revolutionized, which enabled especially the women, empowered them. Okay, so they could save some money, otherwise the men will go and waste all their money. Now they are doing the same thing using healthcare. They are using the Nokia phone, the low cost phone which I use, for transforming their health, because they do not have facilities there, no hospitals, no dispensaries. Okay. Bill Gates builds lot of hospitals, but he forgets people have to travel to them, and there is no bus. If there is a bus, it costs $1, $1 is their daily wages, they cannot afford it. Okay. So, there are a lot of aspects. The wearable doctor or the electronic doctor is going to be the solution. So, we can be part of it. Okay. So, here it shows how using bioelectronics we can make a chip which can measure your heartbeat rate, your steps, your energy, your metabolism, everything. For example, Let us go through this. Check your vitals, okay. Once patients affects this one, okay, whatever the device, it will be useful to collect a wealth of data, the pulse, respiration rate, the activity levels, and alerts the doctor if anything is off base, okay. These are all connected to the Bluetooth or Wi-Fi, it is connected to the doctor's office. So something is wrong, wherever you are the message will go, that is the beauty of it. And then prevent concussions, this is especially true for USA, okay, it is not applicable to us. And then track your medicine. Did you know most of the time the disease does not cure because people do not adhere to the medication procedure, even including me, okay. So when because that is when I realized if I am not following, I am educated, how will others follow, okay. Once you take medication when you are serious.
I can tell most people in this room when they fall sick, when they go to the doctor, doctor gives an antibiotic, he says it should be taken for 6 days, they take it for a day or 2 at the most, because in 24 hours to 48 hours things start improving, they stop it. And what they are doing is they are disallowing others to use the same medicine.
Meaning?
Because the bacteria become resistant and the medicine is no longer effective.
Yeah, we have to adhere, okay. So that is why
compliance is the biggest problem.
They are developing gaming and all, okay, so that you play the game, it will remind it, oh, did you take your medication, because they saw it in the pediatric cancer center there, they made sure the children play the game, and whoever followed it, they had better response rate than others who did not follow it, because you play the game, because these days everybody plays, even adults play the game, correct. So it will tell, did you take your medication, and then like that, okay. So that one, track your medicine, okay. So you can do that one, whether also in addition to.
If I can add one thing here, many people are these days not wearing watches, so but they are carrying these cell phones, so most of these things are coming inbuilt in their cell phone.
Yeah. So here he is telling a sand size sensor which will go to your stomach, and then that will talk about the effects of a particular drug, the metabolism, whether your drug is digested or it is staying as is, all that, okay. Track your medicine, where it is at a given time, okay. And then improve athletic performance, again I do not think we are interested in that, okay. It is like a band-aid. This is another thing I also want to do, like a band-aid. Instead of chemotherapy which gives so much side effects, why not we have like a band-aid or like a patch. It can slowly ooze out, the medication, so slowly it will go to the body, slowly it will work out, okay. So we can do that. So all this I am telling so that we can borrow from this, okay, and then build something which will be useful to our situation, okay. Nurse your wounds, okay. So it is developing tiny dissolvable sensors that can generate heat near surgical incision to prevent infection, okay. Infection, as I told yesterday, 90,000 people die each year in US alone because of infection. Many of them is preventable, okay. So we can avoid that. That is the major problem, surgery. The surgeons won't tell you that, but surgery means infection, remember that. Especially if you are fat, remember it is more hard, difficult to treat them, because the flesh is thick, so they will have more infection because the medicine does not reach the point, okay. So that is another disadvantage of having obesity, okay. And then keep skin healthy. So another sensor, okay, which will stuck on the check users UV exposure levels, okay. So this again, these are all for US, we do not need that. All it tells you is that we can make devices which will monitor, which will enable, which will tell us what is happening in our body, and if something goes wrong, especially for elders, assistive living, for handicapped people, all that, this will be very helpful. Is this clear, the point? So we will see more later, how to build some of the non-invasive devices. For now I want to open with this and then talk about muscle stimulation, because we built that one, okay. Before that, our body and mind are very closely related, okay. Just because you take medication does not mean anything. We have to control our emotions, control our food, control our everything, okay. So too much anger injures the liver because you know you generate lot of acid, okay, which will go and hurt your liver. Too much fear injures the kidneys. Too much sadness injures the lungs. Too much thinking, worrying injures the spleen. Too much joy or excitement injures the heart. Too much emotion injures the heart. Okay? So we should have everything in control, otherwise all our body will be affecting. Okay? So anyway, when we have no control, maybe we will build sensors, devices which will tell us at least that we are exceeding our levels.
Last point, is it the physical heart or the logical heart?
Physical only we are talking here, no logical. Everything, this is biomedical. Okay, it's all related to bio. And then comes, okay, stimulation means you want to put the needle, okay, it can be electrical point needle or it can be normal needle. Acupuncture you all know, correct? All it does is it stimulates those points. That is what if you see our Siddhas told that 7, what is that, you know, the Kundalini, and then there are various okay, points where their energy is concentrated, okay. So here I know the picture is not clear because I made it big. But all it tells, see in hand how many points we have, and then feet only has lot of points, okay, and the feet are really very one of the most important organs of our body. We don't give the enough importance except Bharata, everybody knows Ramayan, correct? He only knows the importance of that, so he took the slippers on his head, but none of us, you know, we treat feet as if it is something not worth it. No, feet are, you know, it holds the whole weight, okay, and there is another picture, I didn't put it. If you see the bottom of the feet, you have hundreds of tiny acupuncture points. So by hitting them we can get better health, okay. So all this tells you we have tons of acupuncture points which we can effectively utilize to enable health. Health is wealth, okay. So here, see how each point relates to what organ, okay. So this point is intestine, this point is bladder, and then this is genitals, and then uterus, kidney, pancreas, gallbladder, liver, duodenum, okay.
Anybody here who reads the hands, that's what they do, they read the hand and say,
you long live, you are going to have fever, that's what. But you need to be an expert, you can read falsely, false positive, false negative, always remember that, okay. That is when they say, you know, actually, you know, palmistry is a science, if you know it correctly, you know. Some people they will do half baked and then they will tell, then it wouldn't work, okay. So yeah, you know, our body, mind, thinking, that's what they say, you know, you are what you eat, you are what you think, okay, you are what you feel, okay. So we can utilize this, and then some electrical needles, electrical points, and then we will be all healthy, okay. Health is wealth, so you will become wealthy also, okay. So here is one thing, I will switch back to the PDF because I couldn't cut and paste everything, it was not allowing, okay. This is the first thing we did it in 2005. This student, he came to me and said, I want to work on this one, muscle stimulator. It's an independent study, could you help? I said very well, because I needed someone like that. So we started it. Is the magnification good enough? Can you read? Or you want to make it bigger? This fine? Okay, so all this tells is whenever you people are injured, okay, we need alternative therapies, because you know spinal cord very difficult, many doctors won't touch you because if one thing, you know, so many discs, if one disc you wrongly do it, you become paralyzed, okay. So it's very difficult, but he wanted to do something related to it, okay. So initially he will talk all those details, and you know, we can regenerate most of the parts using multiple muscle stimulation, okay. So we will come back to that later. Here I want to show you what we did, so I will skip all that. Okay. So, the objective is using common electronic components, okay. That is what this course subject also, using existing off the shelf, okay, components, build a muscle stimulator, then find qualitatively characteristics of the external muscle stimulation. So, you all know what this is, okay. What is this? I know he did not put the symbol, you know, -10 there, okay. So, this is a, you can use a either a inverting with the 2 stages or non-inverting, you can use it, okay. So, all we want is we put some input voltage and then I think he put 5 or 10 magnification, and then you take the output to your skin, okay. So, these are the components, circuit board, DMM, oscilloscope, okay, and Vermeer wet electrodes. Okay, first if you see the, you know, he used then just an you know a electrical wire as thing, then things were he needed more voltage to that, so he wanted to test. This is that Vermeer electrode. It is called resting pediatric resting electrodes. Okay, they use this for cardiac testing of this one. This is what we will be using for our ECG, GMG and all. Okay, so I just thought I will show it to you. So that is what we use. We use both this and that. Okay. So if you want to know background, okay, and normally it is very difficult to repair the nerve damaged, okay, so especially in the spinal cord, and then some techniques purely use biological or organic methods, okay, others use the electronic. So in this case he wanted to find, okay, how the electronic method works. All we are doing here is by stimulating we are providing a new path or enhanced transmission of the nerves, okay, and that way the ions will move from one place to another. I think you know what happens in our body, correct? When we fall and we get a scratch or something, immediately the brain will get the message, it will pump more, okay, cells, go there, go repair it, you know, take care of it. That is why immediately, you know, there will be a bunch of cells coming, slowly they will work and then the reddish will become bluish, okay. So that is what will happen. So all we are doing is we are rearranging the flow of ions in the body to come to the place where it needs extra attention, okay. So here we did not make a device, but this one helps me to do a lot of experiments. So we assume input frequency 1 to 200 hertz, input voltage 1.5 volts, output frequency, okay. These are all just, you know, based on whatever information available, not much work was done at that time, okay. So you should remember that one. So we were just doing out of blue, okay. And then by applying the output of the op-amp to the surface of the skin, stimulation of the muscle can be achieved. So the interface being used to stimulate the muscle is through the end of a 24 gauge wire. I will show you, similar to that used when building circuits, okay. He is really smart fellow, he just used whatever was available, he did not take the time to go and get something, you see. That was the first thing. Then he was not happy with the results, so he came to me, then I told him go and get the electrodes and buy, because by then I started reading about it. So procedure 2 is using that electrode, okay. Again we kept everything the same. You can see here there is a difference in the output voltage and output frequency, okay, using this procedure. So here Vermeer wet gel electrodes were used. Image 2 is the bottom of the electrode and shows the conductive gel. Though it has got the conductive gel and all, normally we wipe with alcoholic swipes and then you apply KY jelly, then you put the electrode, then you connect it, okay. You use an alligator or crocodile clip and then you take it there. So this is the electrode geometry, and then this is okay, he put 2 of them, and then, you know, if you see later slides will say the proximity of these electrodes is important, because if they are too far away you will have 2 parallel circuits, okay, so they will draw more energy. So you want them to be close, but if they are too close also you do not spread the area, okay. So that is, okay, the application of the voltage intensity, frequency, duration, location, all these matter. Okay, it is still a growing science. It is not yet mature, so we don't.
There is one thing.
Yes.
Any test, whether any area, when you are using energy, you would like to use as low energy as possible. So coming back to electrical systems, we would like to operate at create the scenario as it is with as low a voltage as possible.
Yeah, and so normally what do? We find the range. Okay, you apply very high voltage, make sure it burns, then you know you should be below that, and then you calm down. Okay, because you want to know the border. You don't want to, it's very difficult to go from small to higher. So you put the very high, it burns, then it comes. Of course, we have to take what's that? Informed consent. I tell the students, if you're afraid, don't do it, because one student 2-3 years ago, he went and complained to. He's a computer science student. They have to take electrical engineering for non-electrical. Then he's telling that professor is doing this and that. And that head came and talked to my head. Then my head told me, you should ask their permission to do that in future. So I tell them, if you're afraid, don't do it, go and do some simulation. Okay? Who is the loser? Not me. Most of the 99.9% students are good. Some are just crying babies. They want to complain always. So you have to live with it. You don't have a choice. Okay? So here he is talking about, okay, it's quantitatively only. Later if you see experiments, we quantified 1 to 10, 10 is very high pain, okay, like that. Here is the first thing, both for him and me, okay, felt the stimulation and then the discomfort level, okay. So if you felt very high and then the discomfort is very high. If you didn't feel, you don't have any discomfort, okay. So you see here, at low frequency, remember 30 hertz and below, our body is very perceptive, it will feel it. So at low frequencies you feel very much, as the frequency goes high you don't it. Again it depends upon the waveform, okay. He didn't put all that. Again I tell lately we increase to 1000, 5000 as high as frequency. So students really see that variation, okay. For the same intensity, same waveform, you keep varying the frequency, you will see that at low frequency you feel more, high frequency you don't feel. That is how it is, okay, and which is good, so that we can apply something at some frequency. If our body is sensitive to everything, how can we do anything, okay. So that is using that 24 gauge electrical wire, here using the pyramid electrode, okay. Here you see, here he has put voltage, okay, because so with voltage, okay, higher the voltage, obviously you will have more, you will feel it more and you will have discomfort, okay, and then the opposite. So you can see that, okay, again for the same voltage we can do with frequency, or for a given frequency you vary the voltage, okay. So that is how we did, and this is 2005, 2006 I moved to Purdue. Since then every year we do. As I told, I do it in second year, I do it in masters, PhD, all the levels I do it because I want them to feel for it, okay. So I teach applied electronics, so this is applied electronics. So whatever I teach, I will introduce my research things, because people can understand and appreciate, okay. So the first one shows, okay, using the direct wire, 10 to 20 volts at 1 to 200 hertz, okay. Again his skin is different from your skin, because that's what we saw. Some people will come and tell, oh I don't feel anything, okay, go and increase it, and then they will scream, okay. Even I don't feel much until 16, 17, then I will scream, because I will be the first person to test it, because I have to show them that it is not dangerous. If I am afraid, how can I tell them, okay. So normally everything I will be testing first, I allow myself, and then seeing me I can do it, then they will do it, okay. So that's how, if you see originally all the researchers, they are the guinea pigs. You don't go and look for a guinea pig, if you are confident, if you are sure of what you are doing, you should test it on yourself, you cannot test it on others. What do we do now? We test it on all the rats and mice, because we are not sure, or we know it is not going to help us, okay. So this is how you do, you vary the voltage, vary the frequency, and then you distinguish your pain or stimulation effect as nothing, tingling, okay, pulsing, discomfort, burning. He didn't even go there, okay, many people went here, okay, so you'll feel that. Maybe we can do this experiment also. This is my next favorite experiment.
When you say burning, okay, there are two things that can happen. There is a burning feeling which remains subsequent to the passage of the current, number one. Number two is you physically observe a portion of the tissue getting burned.
You don't allow that much, okay, because as soon as it burns, they will take it, or I will remove it or switch off the thing. That's why I always let two people to do this, I don't want to do one person. So one has to be monitoring. No, you don't want to go that one. See, some people will bragging, okay, so you see I got burnt, they will
I
be.
think you should better call it burning sensation rather than burning.
Okay, we can do that, thanks. Okay, some people will be proudly showing it, but some parents, they might sue me telling, oh, Professor Sundarajan did this to my student. Yeah, but normally I believe in God and good, so far no one sued me. When they sue, let me see. I'll cross the bridge. But I tell them, I give the choice. And there are other students, so they know, I tell them, if you are afraid, not comfortable, please don't do it. Okay, I won't take up points, I'll give you something else. We have to be fair, so I will try to be fair. Okay, so here at 20 volts, he starts feeling the burning sensation. Correct, burning sensation. Good point, thank you. Okay, and this is the using the wet gel. Okay, that is using that 24 gauge. So again, he tried with. You see, we need very small voltage in the case of the wet gel and various frequencies. So maybe if you are interested, we can try this experiment, and then we can try at 5000 hertz, and then maybe 20-30 volts, because I don't know, that's what, when I teach the class, my grad class will be Indians and foreigners. The foreign, their skin, though they will be fair and all, they are very strong, their muscle will be really strong because they work out a lot.
But they are more scared.
No, the foreigners are not scared. Our Indians only, where they'll have very less voltage, they'll start, and then, but again, I cannot generalize everyone. Some are really good, but anyway, there are two people. This is the beauty, peer pressure. If one person does, automatically you are forced to do it, correct? So otherwise they will tease you.
They know, peer pressure is what they know.
Yeah, they will teach you, what, come on, like that, they will say, and then he has to do it, okay. Anyway, I will be there, I don't leave the lab, I make sure, if the people are happy and do it well, otherwise, no use of it. Whatever we do, we have to enjoy, otherwise no use of doing it.
One reason why electrical engineering teachers are very tough, because they want to ensure that you don't get a shock in electrical engineering.
Yeah, we want you to stay alive and take our course and suffer, not because of electrical. And I get paid for it. Remember, that's why I tell the student, my job is to harass you and I get paid for it. Why not I enjoy that, correct? Remember, the harassment leads to knowledge. No pain, no gain, okay? So, okay, we can skip all that. Now comes the electrical stimulation, all kinds of choices. Any voltage you want, you can use, okay? Any frequency, any long, any length, everything. Before that, I want to confirm one thing. There are two kinds of stimulation. You can use electrical currents, you can use electrical voltage. What do you think I am talking about, voltage or current? Voltage. Why? Why we are not using current? What's the difference between applying a voltage, applying a current? What's the voltage, what's the current? What does current need, what does voltage need? To have a current. When do you have current? The beauty of voltage is, what is voltage? Let's talk the fundamentals. What is voltage? What is current? Tell me what is voltage, what is current? Current is rate of flow of ions. Current voltage is potential, it's called. But voltage is? What does that mean? Potential difference is called voltage. What is that potential difference do? Amount of work to be done to move unit charge. Okay, that is why remember, where is that? Okay, this one I always make sure everybody understands it.
You got that black.
Yeah, but not now.
Can somebody help?
Remember P is what? Power is dW over dt, correct? Work done per this one. Okay, then we know P equal to V times I, correct, in dc. And then I is dq over dt. V is amount of work done to move unit charge per charge. Okay, so Vi is dW over dq. You know, if you know this is dq or dt, you know it should be dW or dt. You can make it up whether you understand it or not. But if you understand, okay, that is what it is. Okay, the yeah, voltage is difference between the potential in 2 points, but what does it mean physically? Okay, so it is the amount of work to be done. So what happens if you have a battery? You have voltage here, no? Output voltage. If you want current, what you need? You need to have a closed path, otherwise no current. So which is easy to generate, current or voltage? Voltage. It's always easy to use, generate and work with voltage. I wanted to make sure everybody.
Small explanation. See, when you start the electrical circuits, we talk about the sources. We talk about
we move back?
current sources and voltage sources. You remember that? And nobody tells you what is a practical example of a current source. For long, at least in the beginning, you don't understand. Somewhere close to that is a triggered transistor. Okay, when the gate is controlled, acts as a current source. And today, if you want to give an example, the photovoltaic cell is an example of a current source. But the more fundamental thing is, somebody in the back gave an answer, not quite, but which means this: if I draw V versus I, this is my voltage source. No matter what the current that's drawn, ideally it must maintain the same potential across the two terminals. On the other hand, for a current source, no matter what is the potential across its terminals, and this is the very important thing, when we go to pulse generators, you will note one thing: we have to use some kind of an intermediate source of energy storage. So energy can be stored either in a magnetic form or an electric form. So you can either use a capacitor or an inductor. But while inductor stores when the current is continuously flowing, and current flow requires a closed circuit, and any transformation of that energy from one source to other source would call for interruption of that circuit. Therefore, as the current levels go high, it becomes difficult to have opening a circuit, whereas voltage is just collapse that to other. So you will find that quite often we use electrics or electrostatic storage rather than electromagnetic storage, and you will find a lot of capacitors used for pulse generation.
And Mother Nature does the same, you know, our cancer, I all know, the receptors, the interactions, all electrostatic, okay. So it looks like Mother Nature knows better than us. Of course, we learn from Mother, correct? So here,
it's all imitation of nature, what we are doing.
Yeah, we are trying to exploit to our understanding and our ability. We can never, you know, get the whole thing. Okay, so so stimulation can be current and voltage. We will concentrate on voltage in this class, and then voltage can be low voltage and high voltage. Okay, so low voltage is less than 100 volts, which we are going to do. High voltage, we will not be using this. And how many people remember TENS? Some of your biomedical, you should know that, correct? What is TENS? Transcutaneous electrical nerve stimulation. Okay, so we will be seeing this often. What is transcutaneous means? Cutaneous means what? Skin. Trans means across. Very good. Okay. So the frequency is 100 pps or less. Okay, frequencies, remember 30 hertz and below we will perceive higher. Above 30 hertz we don't perceive much, so we can make a choice there.
So I guess the first one must be 100 to 1000 people.
No, this one, what they are speaking. So
no, but the thing is, when you say that it should not be below 100
or less.
Yes, so let's say that it should be above 100, whatever may be the case.
No. Low frequency is up to 1000. So you can go anything below 1000 or less. 1000 to this one. Here you gives the range. Okay, sorry. 1000 pps or less. Here 1000 to 100,000, 100,000 and higher. So you want to say 0 to like that?
No, you said a little while ago that it should never be below 100 hertz.
No. I told below 30 you will feel it. Above 30 you will feel, you wouldn't feel, so you can go. No, we use 5000 hertz. How can I say it cannot be above 100?
I'm not saying that. Now here 1000 pulses per second is 1000 hertz, right?
Okay.
Okay.
Or less.
No, it cannot go less. It has to be, lower end must be 100, 30, whatever you are saying it should, so that you do not perceive it. You don't want to perceive, right, when it's being used.
No, depends. Sometimes you want to perceive, okay? Sometimes you don't. Okay, by the way, the electrical stimulation is useful to do many things like pain reduction. How many of you had accident and I had a current stimulation, I had a serious accident, both cars were total and all that, okay? But they give you current stimulation 20 minutes, okay? Here we are talking. So pain reduction. Another one, edema control. What does edema means? Swelling, it will have a lot of watery contents to reduce that one. Wound healing, especially diabetic, okay, we can reduce lot of amputations. Each day 200 people lose their feet. Not everyone knows that, okay. So we can avoid that by applying electrical stimulation to allow the nerves to grow, okay. Though they say neurons are not regenerative, that is not correct. Our brain is always regenerating. Only thing, the rate of rise is very small, okay, it is very small. So all our body is regenerative, okay, under the right conditions. So we can have for wound healing, pain reduction, edema control, and okay, all those purposes we can have regeneration. That's what the IEEE paper. This guy, he was in the Iraq war, below hip he cannot work. They apply stimulation. You know what, I was so happy to see that they use similar values that which we used in, I don't know, we'll do in the break, I'll find out. Okay, so that fellow could stand for a few seconds. It's a big victory. So they are still trying. They are trying to make a program so that they can apply. Remember, there are 16 electrodes, 24 electrodes, 17 electrodes. There are so many frequencies, so many voltages. Which one you use? Okay, by chance he stood, but we need to make it like a science so that we know which one to use, which part. You saw the acupuncture point, correct? So we had to know in the thigh means, which place to use, what level we have to know. So they are still working. A doctor, she is a brain surgeon, okay, and then she works with the computer science department, University of Louisville, and they are working on developing a software so that they.
I also read this article.
Okay, find out.
How much amplitude?
They use like 10 volts and 30 hertz, 10 hertz, and yeah. Current.
Current magnitude.
Not current, voltage we are talking. Here this is carrier frequencies for currents, but yeah, we are not talking about current. It's all voltages what we are talking. We'll get that.
No, this slide is mentioning current, so where are we? Is it?
No, this is giving you an idea about what are the currents, the frequencies. Okay, I'll skip. Waveforms, okay. So these are the various waveforms. You can use monophasic, you can use biphasic, interferential, pre-modulator interferential, Russian, TENS and microcurrent, okay. So we will skip that TENS, we will see Russian, they use certain frequencies, that is called Russian. Interferential, you use two waves, the difference will be the frequency, okay, like 1000 hertz wave, you apply 1000 hertz and 1100 hertz, two waves, and then okay, the difference, the 100 hertz will be the there. You know monophasic, biphasic, right. So if you see in all our cases we used biphasic, we did not use monophasic. We used in the lab, you know, it is electronic lab, and the pulse, what is that, waveform, what do you call it? The generator, pulse gen, huh?
Function generator.
Function generator, yeah, I do not even know that name, okay. So use that, I tell them play with it. So use, some people use ramp, some people use squared, some people use sine, and then you know I tell them, you know, find out which is giving you more sensation and all that, okay. Monophasic, you know, okay, you can use either negative or positive, it is unidirectional, okay. And twin peaked monophasic, no, we will skip monophasic because I know only biphasic. So typically they say 75 microsecond as the pulse duration. If you see in our case, we were applying.
Now when you say pulse duration, decay to 10%?
You know, we do not do all that, in medical doctors cannot understand all that. So
but how do you define the pulse duration for them? See, a technologist makes it and gives it, so they use that.
you just say 75 microsecond from beginning to ending.
No, but the end will be.
End should be 10 to 90 as you said, but you are an high voltage engineer, you know all that, everybody does not know it. So
No, pulse shaping, everybody knows, Millman taught.
I do not think everybody remembers it also, at least, okay. So thank you, this is the first time anyone asked that question. You know, how do you measure pulse? What do I care, where do you measure? I apply the pulse, I get cured, I walk.
At the end of this course, they should be able to measure.
They should be, not me, okay, you all better learn, not me. That is a good point, but you know, it is 10 to 90 normally, you know, the default is 10 to 90, everybody knows, because we cannot know the beginning of the pulse, end of the pulse. So we start from 10% of the magnitude up to 90% of the magnitude. Biphasic, positive, negative, symmetrical and asymmetrical. Mostly we use only symmetrical, we do not generate asymmetrical, okay. Whatever the function generator gives, that way, okay. Interferential, okay, you use two channels at different frequencies, okay. So it will have less skin resistance, okay, and some cases you use 4 electrodes, okay. 2 will be applying the voltage, 2 will be measuring the output, okay.
What exactly do you mean by less skin resistance here?
Less skin resistance here means you feel your sensitiveness will be better with using 2 channels and 4 electrodes. And exactly how it is, I never measured it. So if you want, tomorrow we can try all that, okay. We can skip one of the other labs, we can try with the electrical stimulation, because this is really very practical, you know. We will take a vote and we will work on it. Yeah. This I did not do it, so I cannot talk much.
What I am trying to understand is physically, how does that happen? Let's say you take a single wave of a particular frequency, monophasic, you get a certain resistance, let's say, and then you have biphase, you take this separately, that separately, frequency 1, frequency 2. What you are trying to say that when you combine 2, the resistance is lower compared
No, this is not monophasic and biphasic. You send.
It is not monophasic, biphasic, but it is interferential, that means simultaneous application of 2 frequencies. So what I was trying to say is, trying to assume that the skin is a linear model.
Skin is not a linear model.
Let's see, even if it is not linear, on an instant to instant basis, it's going to be linear.
Okay.
Okay? So at that instant, I measure the impedance applying 1 separately, 2 separately, and when you say it is less, this resistance in the situation having both is less than either of them. Is that so?
We will measure it tomorrow.
Okay.
That way we will know correctly.
Okay.
I don't have experience in it, so Does it tell you something?
Okay.
This is a good homework problem. Okay.
I'll keep asking.
Yeah, teaching you cannot tell everything. You have to let the
No,
students
it's,
to explore
as I told
some.
you, it's an interactive thing.
Yeah, interact.
I'm putting myself in the place of a student and then
Yeah, ask questions, but every question cannot be answered, will not be answered. Okay.
no, it cannot be answered. Will not be answered is not tolerated. Go ahead.
No. I read it. 10 ideas for teachers. Don't give everything. Don't tell everything.
That is not to be told here. You're not teaching teachers, you're teaching combined participants.
So what? Whoever it is, I am the teacher. Right? Okay, pre-modulated IFC, bipolar electrode configuration, mixing of currents occur. Okay, here he talks everything current, but we are going to do only voltage.
This
Okay.
current, when he means, is like what we say AC/DC. You're saying direct current or alternating current. Is it current? It's
The voltage.
that basically flows the current in alternating manner or direct manner.
No, there will be some current because of the effect of applying the voltage. Okay, so some people. That's the thing, these are all done by medical people. They wouldn't know the difference between the voltage and current. Do you know that? They won't know what is resistance and all. So they talk it. So if we want to finalize, we have to do it. We have to feel it. So that's why I put the first one, because I did it, so I know how it is. Okay, everything else we have to take it with a pinch of salt. Okay, Russian. The classical Russian stimulation involves 25 Hertz carrier. So we cannot beat them because they know low frequency you will feel it. Okay, with the beat frequency from 1 to 100 Hertz. Okay, so you will have the difference from 1 to 100 Hertz, and then this is supposed to allow more current to reach motor nerve at lower intensities. Again the same thing. Okay, less resistance means more intensity. Results have never been duplicated. What does that tell you? Not usable. You have to risk at your own, because we cannot reproduce. Human beings are very heterogeneous. Okay, just because you cannot duplicate doesn't mean anything. Okay, if you want, use it, otherwise don't use it. Okay.
One more clarification.
Yeah.
We are injecting current, or we are applying the voltage with high frequency. The heart will be working at some rate. This won't affect.
We apply for very short duration, and by the time it travels to heart, no, it doesn't. But tomorrow I'll tell you what they do in one case. Okay, normal. Remember, this role I have done. I'm still alive. Okay, so I think it doesn't hurt. Intensity is very, very low. Remember, heart will need at 10 milliamperes. We have very small current here. Okay. There is difference in the duration and intensity, everything matters. And yes, I'll tell you tomorrow more about it.
You again look back, in insulation engineering, what you're doing. You take a sample, okay, and it is expected to operate in a particular voltage, maybe AC or DC. When you are looking at testing it, you test probably around 2 to 3 per unit for the power frequency or DC, and go almost anywhere from 5 per unit to 7 per unit when it is in pulse. Same thing also.
But what I am thinking with respect to frequency.
No, frequency.
Intensity also matters.
Intensity also.
Intensity is very important. Otherwise, you can apply all very low voltage.
Very, very simple.
Keep
I ask you to run, okay, at a fast rate. You will do for a certain distance. I ask you to jog, there may be more distance. Brisk walk, more distance, more time. Walk.
Very good. Very well answered. I don't think I would have answered that well. Thank you. You know, he answered with insulation itself, you know, using your own expertise. Excellent. Okay, microcurrent, I told you, they apply 20 milliamperes. Okay, this is what they do in most of the, you go for what do you call, chiropractor there, what do you call here?
Chiropractor.
There, here what do you call, the same?
Physiotherapy.
Physiotherapy, correct, physiotherapy, that's what it is, okay. Subsensory or very low sensory.
Okay. He uses him actually. His father is orthopedic surgeon in this place.
Oh yeah, yesterday you told me, okay. So, here we use, okay, subsensory or very low sensory level. 20 milliamps is lot of current. Very small current amperage, very high pulse duration. I am sorry.
You give your phone here, I'll put it in silence.
You know, normally I don't get phone. When I teach, everybody calls me. Okay, very theoretical, not much supporting research, attempts to re-establish. Okay, leave all the negatives. What I want to tell you is we can use voltages at certain frequencies and intensities to stimulate our nerves, muscles, and then we can really get benefit out of it. People have benefited, okay, I have benefited, I don't know about you. So we can do that, and we, you know, the voltage levels are 10 to 20 volts, and the frequency you can use lower if you want to sense it. You can use higher frequencies if you don't want to feel it. Okay, again, you know, there are certain guidelines, people use that one. Is that clear what we are trying to do? Questions? Okay, so here now more, okay, what are the,
We have about 2 minutes, I think you can
Oh.
have a discussion and then.
no, I want to finish this.
Okay, fine, finish it.
Okay, so we can have subsensory and sensory pain relief and edema control, and motor nerves, pain relief, edema control, muscle re-education, or you can call it regeneration, okay, then noxious. So these are the various applications, and if you see here it's missing wound healing, you can you can add wound healing also, okay. Subsensory is the microcurrent, we just saw it. Unable to stimulate nerve or muscle, okay. Variety of recommended parameters, generally 2 to 10 minutes, okay. I used to, they used to, yeah, 2 10 minutes they use it for me, okay.
What is the TX? 10 minute?
Durations, I don't know, TX I don't know, but it is basically duration. So the parameters, the first treatment 30 Hz 600 microamperes, second treatment 0.3 Hz 60 microamperes, okay. So you will feel this one, you won't feel this one much, okay. Then pain mode, frequency 30 Hz, intensity 80 to 100 microamperes, healing mode 0.3 Hz 20 to 40 microamperes. You see that when you want to heal, you have to feel for it, then only you will know whether you are healing it or not, okay. Here to reduce the pain, it's really, you know, they will pass the current, it will be like, you know, tingling feeling, you really, you feel nice, I don't know.
Is there anybody who has never got a headache in this room? Among these people, all of you? No headache?
Everybody gets headache, right now they all have headache, I think.
Now, have you observed the headache tends to peak just before it gets away? Observe that.
So you get lot of headache?
Who?
You?
Yeah,
Okay.
I have come across few people who have never got a headache for 40, 50 years in their life. That's
Maybe they didn't feel it, their sensitiveness is not good. Okay, so yeah, I will 2 minutes mean I will skip everything. It has lot of information. Okay.
We'll take it up after the break.
No, after the break I have to talk other things. I cannot talk only one thing.
Yeah, conclusion. Yeah.
Okay, this is what the take home message. Why it is not reproducible, each person is different. The same person, you know, once you give a stimulation, you try after tomorrow, you are a different person. You don't know, our cells regenerate how often? How often our cells divide and how often cells divide? We are not, remember they say in a river the water is never the same because it keeps running, and this similarly.
How often do our cells regenerate?
Or divide. How often cells divide?
It takes mostly 18 hours to do so.
26 to 30 hours. 24 hours, that's why we take the pill.
Okay?
And then the fastest growing is hair cells. If you men can watch it. Morning get up at 5 o'clock, shave it. Evening 7 o'clock you will see it started growing. Okay? So 12 hours for hair cells, of course it varies, typically 26 hours. That's why they give medication and all, because 24 hours is the ballpark, okay, whether it will go into our body, digest and come out. So you give that whole cycle 24 hours, okay, but it takes 26 hours. So we are never the same person. In Tamil we say Indru Pudidai Pirandom, okay, that means we are born today. Every day we are born, okay, so happy birthday. Thank you.
I think we'll take the break. I hope you are enjoying. That's the most important thing. Enjoy the process. Get sensitized.
Are we ready? Yeah, remember we were talking about medical devices. So this is one of my dream device. I have 3 dream devices: cholesterol, blood sugar, pressure, measured non-invasively. Okay. So we tried to. I am yet to do that the diabetic one. So maybe one of you can help me. We can collaborate. Okay. So this one I know. What's your name again? Anthrip. He is using what's that? Photoacoustic to avoid the
Ion is using.
ion. Okay. Okay. Oh yeah, ion. Oh, where is he? Okay. Okay, here remember this is how, remember I am still growing and learning. So I was teaching in 2014 January in IIT Madras. I was on my sabbatical. I taught this course, biomedical instrumentation. So I told them to build a device. So Praveen actually joined later. He tried something, didn't work. He joined them. I said, okay, he's a good student, so I let him pass by. Srihars and Chaitanya, okay, very good students. They did very well. He's doing PhD. He's working. Praveen was doing PhD, converted to master. He just graduated, got a job in Bangalore. Okay, so I am in touch with all them. So we are going to estimate blood pressure using PPG, the pulse oximetry output, and the ECG output. Okay, because remember in my class first lab will be building the ECG amplifier and testing it. So we did that all. So it was natural extension for us to get the PPG and then work on that one. Okay, so we used the circuit done in the lab for ECG acquisition. Of course, they rebuilt, I think, because they used the same breadboard to build other things. Okay, so they used 100 hertz frequency, okay, for sampling. So they removed all the high frequency components using MATLAB, find peaks. So this is the original signal. You do the manipulation in MATLAB, okay, remove all the high frequency components and detect the peaks. And then get the PPG signal, okay, from the forefinger. So I was also there, and then using an infrared LED and a photodiode. So you know all this. Resulting signal, okay, was amplified and processed. Okay, pick up the double derivative, give us the foot of the PPG signal. So again you take you to the MATLAB, do the double derivative, okay, d over dx 2 times, and then you get that signal. Okay. Then we find the location of the peaks in the second derivative of the PPG signal. Okay, this corresponds to the foot of the original PPG signal. Why second derivative? dx over dt, d square over x over dt will give you the maximum, correct? And then you find the pulse transit time, okay, VTT measurement. So pulse transit time is measured as the difference between the OR peak in the ECG signal and the foot of the PPG signal. Okay. So here is the PTT. Okay. You take the peak of the ECG and then foot of the PPG, okay, and then you calculate then. This is the second derivative of this the PPG, and this the port. Okay. So we find now the difference between the peaks in the 2 signals and multiply that value with the sampling rate to get the time duration. Okay. And then the signals were obtained for 10 seconds. Okay. 13 peaks were observed in both of them. The PTT in seconds was found to be in these locations. Okay. I do not want to repeat them, 13 peaks. And then mean PTT value was found out. Okay. You take the PTT value for various peaks, 13 of them, and then average them. Those are all easy, only finding the second derivative and then doing that. Here is this, okay, I have the paper if you want the reference. This gives you the details, okay, BP equal to delta BP divided by 0.7, and then it is calculated using rho d square over 1.4 p tt square plus rho gf. Okay, so use these values and then they measured this 136 over 80. Because this is similar to normal values, I was very happy and everybody gets A and they all left. So that is the status of this project. So again, if anybody wants, maybe tomorrow we can build this also. I know tomorrow we cannot build all, but I am telling these are the various avenues
Today
of
and tomorrow. Yeah. Today afternoon is a lab.
today.
No,
Yeah.
it's not no more tomorrow, it's today.
Yeah. Today we will do ECG, EMG, EEG. Okay. Then tomorrow we will decide whether. Okay. Tomorrow also we can do pulse power, electrochemotherapy. The other 2 days, field computation and pulse power generation. There we will choose. Okay. We want to do this or that or everything. We will stay late. Questions?
For this any substitution, circuit.
ECG, no. ECG measure, no. You build ECG today and measure it, keep that one. And then PPG, you have PPG there, correct? You have in your lab. So we measure PPG, we take the double derivative and then measure this thing, then use the equation. At least you can try, because you'll have the pleasure of trying it. Remember, everything, failure is the first step to success. Okay, it's only first step. We cannot keep on failing forever. Okay, we'll fail first time, then we'll go to the next step. Questions? Okay, so where is he? Who builds the photoacoustic? Yeah, talk about yours. Compare. Tell me, which is better and why?
Better in terms of better. Better in terms of what? What did you want?
Define better first. That's your question.
Something which is giving us more benefits in terms of better.
No, usability, cost, manufacturability.
See, there are two things. Technologically, you are making a measurement, let us say. It's a device for measuring something. So how good it measures, how much accurate it is, how sensitive it is, how precise.
easy it is.
How precise is it? Then comes the ease, then comes the question of cost. Okay.
So in terms of
Ease is very important.
ease
Ease
of
of use. Otherwise,
ease of
you
use
can
of
have the
PPG.
best thing. No one will touch it.
is obviously much more easier to.
Obviously.
Yeah, you just have to put your finger in, and the rest of the computations are done by computer.
Okay.
When you're going for that conventional blood pressure measurement,
Okay.
we need experts over there. And
Okay.
there is a question of listening to certain sounds. They call it thirds actually, soft thirds and hard thirds, by which they define certain pressures. And I've seen doctors actually; they are also not very sure at times about the diastolic pressure point. They told me that it's very difficult to actually hear the sound using that stethoscope that they use in the ears and stuff.
Yeah, you've seen nowadays in the hospitals, they do have this digital reader, which is
But that is used for SpO2 levels, saturation pressure.
no, even
of
blood pressure is measured.
blood pressure in hospital.
Outward measure is there.
They don't
Yeah.
hear any heart sound, they directly just pump it.
No, there is no need of a stethoscope. There is no need of a stethoscope anymore. How? You need
Yeah,
to.
you don't use stethoscope. That's why I was wondering.
No, I was talking about the conventional method.
No,
the
no,
old
but
That's
conventional-
old.
Yeah.
See, now we are still using it, okay, but that is now outdated. You go to say metros, you go to bigger hospitals, they have a digital thing. They just put it here.
Oh,
Yeah.
that we also have here. That is all. Those two things are more or less same. What we do manually.
No, but you don't need to listen.
Yeah, we don't need to listen, but
that
still,
that subjectivity is lost. They removed them.
yeah, but what I was trying to say is that even if you go for those digital ones, those you put the calf when they use, there is a digital box. We have that in our lab actually. One such apparatus is there. That if you just press the button, after a certain time, it will just display the result, the pressure. But the point is that even in the I've seen a lot of references in the internet and other places where people have said that also doesn't give us very good results, because again when what they do is they try to make find the resonating frequency where that frequency comes and some other sound inbuilt inside the system, those are in a resonating state. Then they define that as the diastolic pressure. But the point is that the diastolic third, the soft third that we call in blood pressure measurement, that is so low that at times that measurement is also not very correct. So still nowadays I was just going through certain medical papers. They refer to that golden standard of blood pressure measurement is still that old barometric.
Manometric.
Manometric sphygmomanometer. So these days, yes,
Sphygmomanometer.
Okay,
means
come back to the
you
question.
need the acoustic third is the important thing.
Yes.
Okay, answer to the question. What was the question?
PPG ECG based things are much more accurate than the
Accurate?
Yeah.
Okay, explain how you do, you measure PPG and then?
In
You said photoacoustic. Where is the photoacoustic there?
photoacoustic.
Photoacoustic is not him. The third
Oh,
side.
sorry, I keep complaining. Okay, your PPG you measure and then do what?
Then we extract certain features out of it. Like from PPG we can get stroke volume. Stroke volume refers to the amount of blood that is coming out of the heart once the heart is contracting. Then we have other parameters like there is a normal PPG pulse. If we see there is a kink. I mean in the downward slope there is a kink, and that occurs because of certain things like what happens is when heart pumps. Normally the entire blood doesn't flow instantaneously all through the body. What happens is there's a mechanical energy that is getting traveled all throughout the body through the veins and other stuff. And the main artery that comes out of the heart that gets bifurcated where our legs are getting separated at that point. So there is some kind of a reflection that takes place, and that reflected part comes out. So normally we take PPG from fingers or earlobes and other stuff. So first, because the heart is pumping, one wave of energy is flowing because of that primarily, and that part is getting reflected and going back there. So what we try to do is we try to calculate. I mean, we have heard, you must have heard terms like pulse transit time, pulse wave velocity.
Just a vision.
Yeah, but that is the thing. I mean, that what we to do is take the ECG peak, and then we say why there is a delay in PPG peak, and then we try to take the reference. But alone from the PPG peak, if we just decompose the main signal into separate other signals, we are able to find that pulse transit time and other things. And after that, there are certain equations. One famous such equation is known as Moynes-Korteweg equation. Those were developed back in 19th century by scientists Moynes and Korteweg and other people. So from that, equations are there, and we can.
So can we do your experiment in 2 days later?
We can do that, but actually I need a bit of time to just to set things up and.
Maybe tomorrow afternoon, then if you need time to set it up.
Yeah.
Not tomorrow, day after.
Today also we can do.
No, we'll do day after. I have work today and tomorrow.
Yeah, that we can do, definitely.
Let's do your way. That way, some of you can come up with okay, my goal is we measure something, either use Zigbee or Bluetooth, transfer to your your iPhone, smartphone, Android phone. Then you put this here, this one shows. You understand? That's it. It's all plug and play.
What we are doing is kind of we have the PPG circuit and everything. We have a finger probe and everything. Next we have a laptop where LabVIEW is installed, and which kind of store the data.
Correct.
And from that we can just do. We are building ECG amplifiers anyhow in the second half. So if you can use them also, then we get ECG as well as PPG from my setup. I'll just bring
No, we are doing PPG your way.
my way.
Yeah.
Okay, then that's fine. I'll just store the data in an Excel sheet and then run the data in a MATLAB.
Yeah, that's why eventually we'll put everything in your smartphone. Okay, that way we can make an app. All you do is connect it. Okay, that information somehow should be transferred. That should show display your sister like 130/70, whatever it is. You understand? That is the goal. Okay, so we don't measure no cuff. If you don't have hands, how do you measure blood pressure? If you are fire accident victim, it's all burnt. How do you measure blood pressure? Okay.
They are measuring in the limbs, lower limbs also they do.
Yeah, you can do many ways, but this way, if
No,
you.
I'm just telling you.
Yeah, you can measure. Remember, you can measure ECG in many parts of the body. I told you, they're putting the electrodes on the chair and measuring it because if your front is not accessible, you're burnt, or some kind of disease. By sitting here, they measure the ECG. That's what they are doing in IIT Madras. Okay, so remember, the pulse travels all over. There are some points easy to access, easy to measure. Okay, we cannot measure everywhere. Blood is everywhere. Why we are taking here? Simple, easy. That's why I look for easiness, and then practicability, then cost. Okay, use it because we want to help people. We want to help ourselves basically. Make sense? Questions? Okay, so this is one. Let me talk about.
These are the three golden points. Okay, ease of access, ease of use, and low cost. That's a thing which you need to look at from the. So since you say the signals are available all across in the body, so from the sensitivity point of view, It depends on where it should be accessible. What are you looking for?
Vein finder.
Huh?
Vein finder.
Will you download that? Yeah, one second. Vein finder was there, no?
Where is it?
You download it. It is a PPT or a PDF.
What are you doing?
You want?
It's
Vein?
there?
It must be there.
No, that's what I opened. That's what I told it got closed and you said this and that. It's not there. Okay, I have to go to email. Sorry, everybody think about your questions.
Download it. Just hold on. Come, you're doing it again and again. Don't come. Give me one second. Yeah, that's it.
Okay, this is the another project we did it in that course. Okay, Mishan and Nayan they did it and we published it in a conference. We got the best paper award. Both of them got job in one got job in MATLAB, another one got in another one MathWorks something. So they both got it. Okay, so I am going to present their slides because we worked on it. Okay. It's in PDF. You should have sent me the PPT. Anyways.
One second. Better way. Yes, you start talking. I will.
I cannot. How was it before? Anyways, leave it. I'll skip all this because when we talk about, we will see that, okay. I think at least many of you would have found, drawn the bread and you have suffered because sometimes they cannot find the vein, they'll poke you, okay. Especially small children and aged people, it's a major issue, okay. Finding the vein, and also a seasoned nurse can do a good job, a newly trained one cannot do it. I have suffered a lot because I am not that fat, still they cannot find my vein, okay. So and then that is I am talking about the hand, if you have to find other parts of the body, okay, it's not easy. So imagine, okay, something like you like a torch, you impinge a LED light over it and then it shows you the veins and then you can go and prick on that one, okay. So that is the goal. There are some devices available, but these are all very costly. We cannot use it in India, so we thought we will try something, okay. So the concept is, remember the vein will have, okay, the vein will have the which blood, pure blood or dirty blood? Oh, we had to speak also at times layman word, okay, so it is the dirty blood, okay, whatever, okay. we are not everybody is biomedical here. Okay, anyways, very good. Deoxygenated blood, whatever, I will use that. Okay, so remember the wavelength of that blood. Okay, the blood in the vein and the blood in the artery will be different. So we are going to exploit that one. Okay, and then comes the question. Okay, how are we going to differentiate using LED? Okay, what kind of LED? Because there are so many LEDs now. Okay, there is, you have infrared and then blue and then what? There are so many. So we had a lot of time spending, almost several weeks spending on that one. Okay, okay, here it is. Okay, oxygenated blood and deoxygenated blood. Okay, with and without the oxygen. Okay, so you see the wavelength. Okay, so this is the oxygenated blood. Okay, so you know it is the peak here, and so the deoxygenator we have to find where it is one. And then again we have to use the electromagnetic spectrum. So we know what are the various lights, we will be using the various wavelengths. So we can exploit that to get the information from the vein. Okay. So this is the concept, diffused IR source, or it can be anything. Okay, we use diffuse to start with, and then serial camera module. Okay, so you impinge the light and then you will see that. Okay, so you capture the vein, the picture of this one in a camera, it will show you the blood vessels and all, and then you will transmit to the laptop, and then you do the digital image processing techniques. Okay, so various, you get the image and you do the various things, and then it will be displayed. That is what they did. Okay. So first they have to find, okay, we did a IR source, because many people used, okay, round LEDs and then this and that, they wanted to do something different. So you see what type of this one they used it like this. Okay, so you buy the LED. Actually I sent these LEDs from US, because by then I asked my student to send this because we couldn't buy it here. And then they arranged this. We did many choices. Okay, and so ultimately they wanted something new, because we wanted to go for a patent. Okay, so IR infrared LEDs, the wavelength is 940 nanometer, penetration depth is 3 millimeters. Okay, so we wanted to use a U-shaped array. So that way, if you can show, it will do like this one, and then diffuse this source, because LEDs can be focused and narrow and all those things. And then the camera module, again I think they bought cheapest camera available. Okay, CMOS type. I think all this is not relevant, but if you need, here are all the details. Okay, the goal is to keep it the cost as low as possible. And then the wireless Zigbee. Okay, so we bought this one, 1 milliwatt. Okay, you can imagine this. See the beauty of this 1 milliwatt and all, you can use energy harvesting, correct? You can easily generate 1 milliwatt, though that is not our goal. We wanted always the cheapest and the best, cheap and the best. And then here you can see that was, I think, Nyan's hand there. Okay, so they use the software to configure and then use MATLAB to do the image processing of it. Again, we had many ways. We use blue LED and all. We didn't put all this here. Okay, so then do the image processing, grayscale, okay, the original image, and then you enhance the image using the threshold technique. I think most of you know image processing. There are various techniques to use. Okay, so again you have to try that. I think this is what they find. Remember, this is part of just the class project, but still they took their time and initiative, and I paid for all that, so it was money is not a concern. Okay, and then using MATLAB, okay, the morphological plot analysis. So they did all this. So this will tell you where the vein is. Okay, and then they found out that, okay, that the vein will have peaks and valleys, neighboring tissues due to that, and then veins due to higher IR light absorption. Okay, so they did various manipulation. I don't think we need. Okay, so we measure up depth of the veins, and then improved visual of the veins. This is what we are more interested in. Okay, we want to see the vein properly and then go and prick it. to summarize, low cost, low power consumption, wireless transmission capability. Okay, why wireless? That's the state of the art, and you don't need any hardware, wires running. Camera selection, okay. Again, you need a very good camera. We went for the cheapest one with the hope if it works we will go for the best camera, okay. And then the probe design, again we can use 2 LEDs or you can use a bunch of LEDs. Again you want to use a circle shape or U shape, T shape. We tried many, we don't show it all here. Yeah. And then again you try various image analysis tool and then you come up with the one. So this is really a good project for students to learn more, not only image processing but also to know the hardware limitations and their capabilities. So yeah, we want to extend it to optimum wavelength and then better probe design. So these are all better quality camera. Onboard processing feature, okay. Remember, now we send it to the laptop and do, but we want to do if we can do everything in one, okay. And then single board embedded system, put everything in one, the camera, the LED, the analysis, everything in one, okay. That's the wish list. And here is the references. So again, this is the vein finder easily. So using our LEDs, our electronics, our image processing, MATLAB tools, we can come up with many devices, okay. There is another one. Do we have time?
We can have one more device.
But I have to open my email.
Your mail is open, it's not closed.
I have one question. What about, once you design this particular thing, in the computer from image processing you just got the vein, right? But then what about the application? It was initially designed because people were not finding the veins properly to inject something on the veins, right? So what about on the real thing? What about
That is, we will give this to the hospital. Whoever is smart, they will buy.
I'll be just, once we use this, I'll be able to see on the computer screen using image processing that okay, this particular portion is my vein. But that is on the image. But once I look with my naked eye to the arm, say I'm not finding my vein properly, still I won't find properly. How do you track that?
No. That will give you a very good idea of where the vein is. Instead of they poking everywhere, you should.
Position, we can't know the exact position.
It is real time. Sometimes it is real time. So
No, when we are poking
as
the
your
needle,
marker.
we should have something from the needle also, right?
Yeah.
For the feedback that we are poking it
Needle
in
is
the
the-
right.
No.
It can be a marker also
Yeah.
where the image will mark. So some ink may be put over there or something.
No. This one is, this is the first thing, okay. So it will show you. So, okay, it's like a handle device. It will show you where it is. So you can see, feedback loop and all is, Those are all, those are all there.
Further on that.
Yeah.
This is the first step, so maybe one
The
module.
technology.
The next module would be to track the needle movement and say that this is the place where it is. See, there is no this thing.
There is no end. Yeah, we had to start somewhere. So we started.
Start somewhere, and probably what she is sharing is some of the devices she has already been associated and developed. It's only to n number of ideas. Okay.
Yeah, see, remember, I did all this. I am not speaking from air, correct? So what is his name? Cholesterol? Nick. This is an undergrad student. Tina. I am sorry, I should have saved this yesterday, I didn't do it.
Cholesterol, so you just say cholesterol.
Yeah, it's not showing.
Cholesterol extraction.
No, she did it, but she didn't do a good job.
Yeah, whatever it is.
No, I'm looking for Nick.
This one you see it's gone again. Yeah, you see this Nicholas.
Taina, okay, that is. He had a poster.
Just see that.
That is a report.
Yeah, just we can read, see the report and start. Open. Control plus you do. Become bigger.
Control plus.
Yeah.
Where?
Control and plus.
Yeah. I'm doing. Zoom. So this is another dream project. We use the cholesterol. Okay, again it's just a starting, because we found something. We need to correlate that saliva cholesterol to the real cholesterol. So we have to get lot of people's saliva cholesterol and real cholesterol, find the correlation and then use it to testing. Okay, there is lot to there, but anyway we thought we started again this paper. This one got a best paper award in a. We have what is called faculty convocation. So everybody display their research and people vote for it. So we got the award. Okay. So total cholesterol is made up of LDL and HDL. Okay.
And told Indians are genetically predisposed to having cholesterol. Okay, and if you ask any of your grandparents, they'll say, no, it's not running in our family. Okay, the reason was at that time we didn't have instruments to measure it. That's the basic reason why they don't know that they have cholesterol. All of us have. Because we eat a lot of rice.
Okay, so what is available in the market is, okay, they have what is called cardio check starter cholesterol analyzer kit, okay, with cholesterol test strips. So we bought this one, okay, and then we didn't bought this one also, okay, we bought this one also, so that we can study all that. I don't know whether I can use this to, I need that poster. I know ECG, he is talking about ECG, okay. Then comes the saliva, okay. Saliva is, saliva has lot of enzymes. I read in one school of thought that, remember, normally we eat immediately, we wash it because we don't want the teeth to be getting there, but when we eat only, the many enzymes will be secreted and they help our digestion. So one school of thought says don't wash immediately, okay, allow 10-15 minutes, okay. After 15 minutes we will forget it, okay. So anyway, saliva is really a good, and if you don't know whether we can pimple and all, we can cure with that, okay. I don't know, you might not know Rajesh Khanna, how many of you know? He is a great paper, everybody knows he is older, my time, dream boy. Anyways, he will have lot. Yeah, Rupatera, I love that. Okay. He has lot of pimples. So people said, take the morning first that saliva, the virgin, put it like that. He will say, oh, where does I get saliva? I only get whiskey, like that. He was bragging. Okay, so like that, the saliva has many beneficial, useful, okay, therapeutic details or therapeutic enzymes. Okay, so we can use that, but still, we have in Indian culture, we don't eat from one person because it also has some things to be contamination. Okay, can cause also diseases, so we have to be careful. Okay, so it is secreted in salivary glands, contains mainly of water, but also contains enzymes and glycoproteins. They all will help in healing and in digesting. Okay. Its major role is to start breaking down food particles, okay, and serves as a lubricant. Check cells can also be found in saliva, and then it is also signaled by nervous and other sympathetically or parasympathetic alley. That is why there is a meaning and purpose using hand to eat than using a spoon. Yes, sir.
Yeah, did you hear what she said in the end? I remember a story I read in Times of India a long time ago. There was a British journal in the pre-independent India. So once he was stuck in a jungle and he didn't have food. So the villagers brought the food and gave it in a leaf. Said, where is my fork and knife? Said, they didn't know what it was. So they couldn't really follow the English also. Then one meal he didn't eat. By evening he felt very hungry. Then he called them to bring the food. He ate the food, said the best fork and knife is my 5 fingers.
Yeah, that's what. Remember when I think Gandhiji or someone, one of the big dignitaries went to Europe, during British period, London, during the, I think maybe Rajaji, yeah, Rajagopalacharya. Everybody was using spoon. He said this is the best spoon because no one else can use it. Correct? It's your spoon. Other spoon everybody will eat it. Okay. So saliva has lot of therapeutic details. Okay. So we can use also saliva and its serum for studying the salivary lipid profile. Okay. It will also have some fat content. So we can study the cholesterol. Okay. So that is the basic concept. Okay. We want to find what is the cholesterol in the saliva and correlate it to the real cholesterol, and then find a relationship and then use that for future. Imagine that, how do we test cholesterol right now? You have to take?
You take blood samples.
Blood samples. And then you have to wait, they don't tell you immediately, you have to wait some time. Imagine this one, that's why my sister-in-law is a doctor. She told, okay, it will be saving so much trouble in the GH and all, People come, take a strip, take their saliva and test it. Imagine, okay, it will save lot of, especially Indian GH, they don't have manpower, they don't have facilities. This will really help, okay, maybe one of you can work on it. Okay. There is a slight correlation, okay, between the saliva cholesterol lipid profile and the blood serum lipid profile. That is our job to find what it is, okay. While the most common and most accurate way of measuring cholesterol is through the use of blood serum, we can infer and predict the profile, okay, that is what it is, okay. We want to do this. This does not replace anything, this only adds on to it, okay. When you do not have the blood test, we can do this. This will give some idea, okay, because remember, if it is a very big value, you know that there is something is wrong, okay. So this does not, none of these things replace anything which is existing, they will be add on to it, they will be like accessories, they will enhance the existing technology and then enhance the quality of life. That is how we have to see it, okay. We are not here to reduce anyone's job, okay. So then comes
Yeah, I think.
Okay, here, give me 1 second.
No, I give you a second, but.
Okay, this is not, you keep talking, I will find the other,
No,
I need the.
We are up with our time, that's the thing, that's what I want to do.
Give me 1 second, please. Dana PPT. Okay, I will stop now. I will compensate tomorrow with the more.
So, now afternoon we are not meeting here. We not no recording in the afternoon. It's only